I'll make the calculation of oxidation number very easy. Click the subscribe button below and watch this lecture until the end. Calculate the oxidation number of sodium and chlorine in sodium chloride. Sodium chloride. Now let me explain each atom individually. Sodium atom, its atomic number is 11, and electron configuration in main shell 281. One is the valence electron of sodium atom because it's found in its outermost shell. Therefore, sodium must lose one electron to has 8 electrons in its outermost shell. Chlorine atom, atomic number 17, electron configuration in main shell 287. 7 is the valence electron of chlorine atom. Therefore, chlorine atom needs one electron to attain 8 electrons in its outermost shell. Now sodium atom lose its valence electron and form sodium plus 1 ion and 1 electron. This sodium plus 1 ions has 8 electrons in its outermost shell, and its electron configuration is 2,8. The chlorine atom 287, it needs 1 electron that's lost from sodium atom, and chlorine atom gain 1 electron and form chloride ion. This chloride ion has 8 electron in its outermost shell, and its electron configuration 288. Now these two ions, that means sodium ion and chloride ion, they attract each other, and finally they form sodium chloride. The oxidation number of sodium in sodium chloride is plus 1, and the oxidation number of chlorine in sodium chloride is minus 1. Therefore, plus 1 for sodium plus minus 1 for chlorine is equal to 0, because the oxidation number of all atoms in a neutral compound is equal to 0. The second example, calculate the oxidation number of aluminum and oxygen in aluminum oxide. This is the formula of aluminum oxides. Now let us see each atom individually. Aluminum, its atomic number 13 and electron configuration 283. 3 is the valence electron of aluminum because it's found in the outermost shell of aluminum atom. Therefore, aluminum loses 3 electrons to attain 8 electrons in its outermost shell. Now aluminum loses 3 electrons and form aluminum plus 3 electron. This aluminum plus 3 has 8 electrons in its outermost shell, and its electron configuration is 2,8. Now oxygen, atomic number 8, electron configuration in main shell 2,6. Therefore, oxygen needs 2 electrons to attain 8 electrons in its outermost shell. Now, oxygen gain 2 electrons that's lost by aluminum atom. Finally, it forms oxygen minus 2 ions. This oxygen minus 2 ions holds 8 electrons in its outermost shell, and its electron configuration is 2,8. Now these two ions, opposite ions, attract each other and form aluminum oxide by crossing their oxidation number. Aluminum 2, oxygen 3. Therefore, the formula of aluminum oxide is aluminum 2 and oxygen 3. The oxidation number of aluminum in aluminum oxide is plus 3 for only one atoms. That of the oxidation number of oxygen in aluminum oxide is -2, only one oxygen atom. But the total oxidation number of aluminum is +6, that of oxygen is -6. Therefore, +6 plus -6 equal to 0, 0 equal to 0, because the oxidation number of all atoms in a neutral atom is equal to 0. Now the third example, calculate the oxidation numbers to the green colored atom only for the following compounds or ions. Now example, sodium thio sodium thionate, sodium tetrathionate. The number of atom here is sodium, 2, sulfur, 4, oxygen, 6. Now let us assign oxidation number of each atoms. Sodium has +1 oxidation number, but sulfur is the required one, so let us assign Y. Oxygen is -2. Therefore, the total oxidation number of sodium in this compound is equal to 2, because we have 2 sodium atom, plus 1, which is equal to +2. The total oxidation number of sulfur, the oxidation number of one sulfur is Y. Therefore, we have 4 sulfur atom. 4 into Y equal to 4Y. Total oxidation number of oxygen, we have 6 oxygen. Therefore, 6 into -2 equal to -12. The sum of oxidation numbers of all atoms in a neutral compound equal to 0. Therefore, +2 for sodium, plus 4Y, the required one, plus -12 equal to 0, plus 4 plus -10 equal to 0, 4Y equal to +10, Y equal to +10 upon 4, Y equal to 2.5. Oxidation number of sulfur is equal to 2.5. Dihydrogen diphosphate ion. This compound known as dihydrogen diphosphate ion, its charge is -2. The number of hydrogen atom in this ion is hydrogen 2, phosphorus 2, oxygen 7. Now let us assign oxidation number of each atom in dihydrogen diphosphate. Hydrogen has +1 oxidation number, phosphorus is the required one. Let us assign Y, the oxygen is -2. Total oxidation number of hydrogen is 2 into +1, which is equal to +2. Total oxidation number of phosphorus 2 into Y, which is equal to 2Y. Total oxidation number of oxygen 7 into -2, which is equal to -14. Now, the sum of oxidation number of all atoms in an ion is the charge on the ion. 2Y plus 2 plus 2Y plus -14 is equal to -2. 2Y plus -12 equal to -2. 2Y equal to -2 plus 12. 2Y equal to +10. Y equal to +5. Calculate the oxidation number of sulfur in iron 3 sulfate. The formula is simple like this one. So, the number of atoms in sulfur iron 3 sulfate, iron is 2, sulfur is 3, oxygen is 12. Now let us assign oxidation number of each atoms. Iron has +3 oxidation number. Sulfur is the required one. Let us assign Y. Oxygen is -2. Look. The total oxidation number of iron is equal to 2 into +3, which is equal to +6. Total oxidation number of sulfur, 3 into Y, which is equal to 3Y. Total oxidation number of oxygen, 12 into -2, which is equal to -12. Sorry, -24. Total oxidation number of oxygen, 12 into -2, which is equal to -24. The sum of oxidation number of all atoms in a neutral compound is equal to 0. +6 plus Y plus -24 equal to 0. 0Y plus -18 equal to 0. 0Y equal to +18. Y equal to +6. The oxidation number of sulfur is +6. Thank you.